Yeah. Oh, sharing. Yeah. All right, guys. Good morning. Okay. All right. All right. So, where were we last time? I know it feels like forever, huh?
You want to start us off by giving us the where to get the files and all that stuff from part one?
Yeah, for sure. That is a great
Or
place to start.
for those that missed part one.
All right. So, I'm just going to go back over to our forum link, and then I'll go ahead and click on the link to the repository with all the notebooks, and I'm going to paste that into chat. So for anyone that's already set up from our last talk, you're good to go. If this is your first time joining, there's a little bit of a setup. And so what you'll want to do is grab a copy of that entire GitHub repository. And in there, there's a set of setup instructions that walk you through exactly on how to get Visual Studio Code set up and to use UV to set up a Python virtual environment and to get all of the dependencies installed. And if you're going to run a large language model or a small large language model locally, how to install OpenAI, how to install Olama and to get that configured. So if this is your first time, go ahead and download the directory, open up that PDF, and then if you just want to follow along the talk for now, or if you could multitask, try to get it set up while we're talking. All of the notebooks are posted to that GitHub directory, and we'll keep this going for as long as there's interest. The last time we met, we walked through the basics of a large language model and how to turn that into a chatbot, and how to use a really neat lightweight user interface library called Gradio to set up a chatbot in your web browser or so where we're going to start today is kind of where we left off. So the first 3 lessons have been updated with everything that we figured out from our last month. So we have Zet's clever little patch to strip out that thinking section so that we don't have any problems with radio. And so just to recap, if we go through and select Notebook 9C, and we select our virtual Python environment that we set up last month. And we need to make sure that if you're running Olama, that we have Olama serve. Running in the background to be able to accept those requests and behave just like the OpenAI API endpoint. And if you're using like your own OpenAPI key or some other thing, you can make your changes here to the base URL and the API key to get that to work just based on the standard instructions. So in theory, if we go in and hit restart and run all, just a recap from where we were last week. I'm gonna follow this along. 1 is done, 2 is done, 3 is done, 4 is done, and in chatbot, in theory, after a certain amount of time, when it loads up the model in the background, processes its thinking tab, this will take me the longest that it takes. We should get an answer. All right, so this verifies that we're set up you've got Olama installed, you've run Olama Serve, and our chatbot that we left with on 2 months ago is working correctly. All right. So with all that as a background, let's take a look at tools. So I'm going to open up one of our new notebooks, 11A. And if you haven't already, we'll select the virtual environment that we have set up previously so that the Python knows has access to all the packages that we've installed in the virtual environment. And there's some text in here, and there's some links on tools that you're free to look at in the background. We've got our chatbot, our large language model set up just like in the previous lesson. Now, I'd like to focus our attention here. Let me invade this a little bit so we can get a better look. For everyone that's here, I'm just adjusting the screen so we get more. And Control Shift plus. All right, let's take that off the side. Let's say, do we really have to take up all this space? What? All right. Pick your battles, Ellen. Okay. Yeah, let's find down there. Okay. So I'd like to focus on this, and you've probably seen this in previous months, the how many fingers on the whole examples of tools. But let's really look at it. There's a couple of really neat things. Now we're using an agent framework, so we're using LangChain and LangGraph where appropriate to abstract away the Python code. You can inspect these, you can right click and see the definition, and you'll see behind the scenes, it's all Python. And you could write all these things from scratch if that's your passion and interest. Mine's not. I want to solve interesting problems using the frameworks that are available. This is one of probably more than a dozen now. In the news, you've seen between OpenAI and N8N and some other ones, there's a new generation of AI frameworks that you configure visually. So who knows? Next time we talk about this, maybe we'll switch gears a little bit. But for now, what I want to start with is that a tool, something that you hand to the agent to be able to use to do a thing, is at its basis a Python function, right? We have a def, we have a name of the function. In this case, we're not even passing any parameters. And we're going to be fancy, and we're going to, in the declaration, define that we return an integer, right? So this is standard Python functions or 101. Now, this function, if you ignore some of the decorations, returns a random number between the random n is weird, but it's supposed to return between 0 and 10, right? How many fingers am I holding up? If you're considering I have 2 hands and 10 fingers, which for now is true. It just returns a number between 0 and 10, right? So Python function 101. Now, there are a couple of things that we're going to do that makes this function compatible with the framework. The first one is we're going to use a decorator, which adds some Python boilerplate behind the scenes called tool. So we're going to import that decorator, and then we're going to decorate the function with tool. That sets up this function in a way that the framework can use it and add it to the list of tools that are available to the agent to run. Super simple. The next thing is we're going to add in some triple quoted text. Now, I never remember what that's called, but that triple quoted text, because of this tool decorator, it provides this description to the agent. So triple quoted text tells the agent what this tool is for. So it gets a list of tools. It says, okay, the tool is how many fingers, and it sees as part of the tool definition, for any questions involving how many fingers are being held up, return the total number of fingers. And so that's the only difference between a standard Python function and writing a tool. We've got the tool decorator and a triple quoted string that is passed to your large language model that describes what the tool is for and ideally how it's used. And that's it. That's it. So we're going to expand on this a little bit. And if you're following along, go ahead and run the cells. With those in place, let's run a couple of print statements. Oh, what did I forget? Oh, sorry. I haven't run any of the code yet. So let's go through and run the top cell that describes the LLM as being an instance of Chat OpenAI. Let's run the cell for code that defines the tool, how many fingers. And now that we've run the cells above, we get 3 values. So this enumerates through the types of information that's being passed back to the large language model. Telling the large language model, giving it some clues on what the tool is for and how to use it. So the large language model has available to it what the name of the function is, how many fingers. The name of the function gives the large language model a little bit of a clue as to what it's for and how it's used. But more importantly, we're providing the help text and the description. And finally, what arguments are passed in order to do the thing. This is your super simple one. There's no arguments. So we have a set of open, close curly braces. There's nothing to pass along. So the next thing we're going to do, because of that tool decorator, it gives us some complementary methods or functions. The most important one is invoke. So let's do a quick how many fingers dot invoke. And based on that random number generated between 0 and 10, we've got 9. We'll run it a couple more times. 10, 7, 1, 8, 5, 0, 8, 7. Okay. So very similar to just calling the function on its own, but it's set up in a way that the LangChain and LangGraph agent framework can use it. And so for the next one is let's write something a little more complicated. This is all kind of background, right? To get you comfortable with the concept. We'll do another one. Let's define another tool called multiply. Let's say we want to give the agent the ability to do math. Now, if I skip back over to our chatbot, this is actually a fun thing to do. I'm going to switch back over to the 9C notebook. And so you can chat with it about anything, including asking it questions. So let's test the raw chatbot, the large language model, without any tools. What's 9 plus 9? Now, you know computers are smart. They do calculations all the time. It's easy to assume it should be able to get the answer right. And for small ones, it does. And the question is how? Like at this point, 9 plus 9 is 18. There shouldn't be any surprise of it. But if we do something more complicated, like what's
Calculus?
Huh?
Like do calculus?
Right. 9 plus 7 to the power of 2. Now, as you go through it, it gets some of the easy ones correct. I want to talk about that for a second as well. Now, I'm trying to come up with something that's a little more complicated. 13 to the power of 2 is 13 times 13. So 169. It's still thinking about it.
But wouldn't PIM just kick in right there?
Yeah. Order of operation.
Yeah, order of operation would have kicked in and done the power first.
Right. So there was an ambiguous thing in the station in the statement. But what you're going to find is that for simple math, it kind of gets it right. For more complex math, it guesses, it hallucinates. Now, this large language model has been trained on the corpus of all available human knowledge and then compressed based on the size of the model, right? It gets the gist of English with fine tuning. It gets the gist of being helpful. Always wants to be helpful. It's probably memorized a bunch of these answers to really simple math problems. But when you go to things a little more complex, it no longer has the gist of it and it hallucinates. And it's something that you'll want to play with to find the limits of, let's say, a 4 billion parameter model and larger models like ChatGPT or Claude. There's a limit to the math that it's memorized the answers to. And if it hasn't memorized the exact answer, it tends to hallucinate something that's plausible, and it shows the limit of it. It can't do math, it's memorizing the gist of math. So, but I want to focus in on our talk today, and we're gonna skip ahead so we can, play with it in the time allotted.
Excuse me, what you
Yeah.
just said is a very interesting statement. You said it can't do math, which is true. It just memorizes the answers. But at the real core of it all, it is doing math. At the actual level of the processor.
Behind the scenes, everything in your squishy brain and everything hypothetically and everything in the neural network that forms the base of it's just math.
Yeah.
Gradient descent.
It's just at the highest level of description.
Yes. Yeah. So that's like Alan, why are you focusing on a math tool? That's lame. It does math. It has the gist of math. It knows it has memorized the answer to a large swath of simple questions, but it's going to fall down at anything that is outside of what you see out of the norm. So that's why we're focusing on the math tool first. And a tool can be anything. We'll look back to that in a second. So we're going to define a multiply tool. Now, in order to multiply, and this is super simple, I just accept two numbers and they're integers, so nothing fancy. We've got the tool decorator. We have a description of what the tool's for or what it does or how it works. And then we just return A times B, right? Another super simple. This is Python 101 with the exception of the triple quoted description text and the tool decorator. So let's go ahead and run that. We'll run our three print statements. And again, it returns multiply as a description. It understands multiply two numbers. But look here, we have a little bit more information about the input parameters. There's two parameters labeled A and B, and they're of type integer. So there's some mechanism in this framework that is able to introspect, is able to see how it's defined, and it's able to return that textual information back to the large language model. So that's pretty cool. And if we do a multiply invoke, this is Python. This is going to work every time without hallucinating because it's a tool that actually does the math in the background. Now, yeah,
Just when you print out the signature and it had A and B, it had capital A and capital B, so it did transformation.
it did. I'm not sure about the mechanism behind that, but yeah, that's a good catch. I did notice that
And
as well.
I wonder, can I put descriptions on parameters, or if you're not got that deep?
You absolutely can, but I didn't explore that in these
Okay, no
examples
worries.
because yeah, there's
That's interesting. It's like,
yeah,
what's
yeah.
it doing?
Yeah, because you and I are working on that specifically on the MCP side, right? And on the MCP side, you do the same thing and you can embed a lot of information in the parameters as well. I didn't get to exploring that in the tool ones. I got as far as exploring the description for the tool itself. But yeah, I wonder, it's a good thing to look into.
I guess it would be the Python, since it's title, then it puts the title case.
Oh, perhaps, yeah, that's a good guess. Yeah, for sure. And because this is just Python, we can do obnoxious things like, type in numbers that certainly wouldn't have been memorized, and it just does it because this is Python and it's literal math. So there's a couple more things. I'm going to skip ahead a little bit. There's a step where in order to make these tools available to the large language model and the agent, you have to put them in a list. So this is just, you're defining a list called tools, and it contains the names of the two tools that are defined above. And I'm going to skip over the rest. It shows here that in order to use tools, you have to have a version of the agent that can make use of them. And so that section up above just shows that it's the wrong agent for that. So in this lesson, the last thing that I'm going to bring in front of you is that there is an out-of-the-box agent built into the LangGraph framework called Create React Agent. A React agent is a very neat type of agent. And it was first described in a paper all of 2 years ago, maybe 3 years ago. We're now in a time where anything 2 years old is considered old news, but it's a contraction of reasoning and action. It's an agent that is able to reason, come up with game plans about how it wants to approach a problem. It can look at all the tools that it has. It can concoct a game plan to leverage those tools to answer the question, and then to answer the question, get back to you. And you get all that for free. And there's a fascinating amount of approach in Python code behind the scenes that, if you're interested, you could look into simply by right-clicking and going to definition. But for our purposes, I just want to make use of that. And I can make use of that with basically one import and one line of code. So we define an agent as an example, an instance of Create React Agent. We pull in that model definition that we already did above, right? So that chat OpenAI, we still make use of that because we need a large language models to support it. And we're going to pull in that tool list that we defined above, right? So let's go ahead and run this. To define an instant of agent, I wasn't very creative. You can call it whatever you want. This is just a placeholder or a variable. For
Can I ask
instance,
a great question?
Yeah,
I see what you have highlighted as the word agents, but 2 lines of text down, there's a statement which says in lowercase tools equals tools. Isn't that an empty tautology? It has no meaning.
you know what? That's a great question, and it throws me for a loop as well. Fortunately, Python's smart enough to understand what my intent is. When you, yeah, no, it's a really good point. And personally, I think that was a bad habit, what I just did, simply because it reads weird. So the Create React Agent, when you create an instance of it, it accepts all manner of parameters. And one of the parameters is called tools. Now, up above here, I declared a list that contains my 2 functions in it, which is also called tools.
Right.
Now, fortunately for us, Python's smart enough to know, based on how I'm calling it, that the tool parameter relates to expected optional parameters for a Create React Agent, and I'm passing an instance that's also called tools. Now, I was being lazy, and it's a good catch. A better way of approaching this is to not reuse those. So let's say for sake of clarity, I should have done this, and you're absolutely right to call it out. Instead of saying tools, let's call it my tools. Now, when we get back to the declaration of an instance of it, now it passes the visual sanity check, right? And it makes a lot more sense. But yeah, and I guess, the lesson that you're pointing out, and I agree with, is just because Python's smart enough to figure it out doesn't mean you shouldn't make it easier to see visually. So we'll do that. So we've got an instance of our agent that is able to call the LLM and has a couple of tools. Now it has 2 tools. How many fingers am I holding up? And a multiply tool. So let's go ahead and because the agent works in terms of messages, and the messages have a certain format, instead of passing in just some text, we have to say the message that we're passing in is in the role of the user. It's a standard message format. And what's 9 times 27? And we'll do an agent invoke. And we pass that input message, and we'll see what it says. Now, before we get to that, let's just try the easy one. How many fingers am I holding up? Let's try our simple one. And let's see what it does. All right, so here's the trace of its entire thought process. So it's really amazing. It's showing you exactly how it approached it. Here's our human message. How many fingers am I holding up? Here, let's small this a little bit. And it's like, okay, I need to call a tool. That tool I need to call is how many fingers, and it calls the tool, and the response back is 0. So it takes that raw response of 0 and it translates that into something English. Yeah, come on in, you're just in time. And it says the answer is 0. You are not holding up any fingers. So it even does a little bit of embellishment to make it like an English language suitable one. So let's go back up here and say, what is 232 times 1904? Okay, so I'm going to run this. Can someone pull up a calculator and use it to verify the answer? So 232 times 1904. Someone got that for me? 232 times 1904.
441,728.
All right. Oh, perfect. Thank you. Let's give it a chance, and we'll look at the trace, and we'll verify that it got the right answer. All right, so it got the question, 232 times 1904. Tool call, it decides to call the multiply tool. It passes in the 2 arguments. And 44, 17, 28. Did it get it right? Yep. All right, so check this out. Couple lines of code. And again, it looks arcane and it looks complicated because we're taking a long way on talking a lot. But at the end of the day, in a few lines of code, we can pass arbitrary functions as tools to that LLM. And in my opinion, tools turn a chatbot into an agent. You give it any, and it's able to leverage any tools that you give it, that you explain what they're for, and they're how to be used. Now, to skip forward a little bit, like, okay, we've got a multiply. Let's do a subtract. Let's do a multiply tool, and let's do a divide tool. And now we've got like a simple grades tool calculator. And I would encourage you to do that. It's fun to do. You define the functions, you add them into the tool list. And after that, it's able to, based on your question, know which tool to call, and it can do that math. And from that point forward, your agent can multiply, subtract, add, and divide. I don't know why I chose that order, but that's the way it is. But there's got to be a better way of doing that. So knowing that Python's good at math and agents are good at calling tools, let's take a look at tool use 2 to see how we can approach that. So I'm going to open up 11b, and I'm going to select my Python virtual environment in case I hadn't already there. And let's take a look at a more general way of giving your agent the ability to do math. And so let's just see what we have here. We have, some imports from the previous lessons. We call in, we define that LLM chat OpenAI, just like we had in the previous lesson. And I'm going to show you this a couple of different ways. We'll end up with, hey, your chatbot can do math. Of course, that's in the last lesson. But I want to explore this in a couple of different ways. And the first way I want to do that is by just, trusting me that this is a simple way of doing arbitrary math. So we have our tool decorator, we have our tool name, evaluate math. It accepts a string and it returns a float. That's interesting. And we have our triple quoted string, safely evaluate mathematical expressions written in the Python syntax, supports basic arithmetic, and it gives some examples. So here's a way of giving the agent even more information about the proper use of the tool. So you can see how powerful this is, right? So it's describing exactly what it's for, as well as how to use it with examples. Now, the rest of this, you're going to have to trust me on just for a second. It parses the expression, it compiles it, and then it evaluates it. So it runs the Python code provided, and it returns the result. Now, as amazing as this is, and we're going to try it down below, I'm sure some of you that are more security focused, little hair in the back of your head's being raised up. And they're like, hey, smart bald guy with the funny shirt. How wise is it to give an agent the ability to run arbitrary Python code? And you are 100% correct. But I wanted to keep this example simple just so that we could see mechanically how it works. And then there's something, if there's two things I want to impart upon you as well as this task. The amazing ability to give your agent the ability to do things in the world through this use of tools or functions is the primary one and how easy it is. The second one is I want to reaffirm for you how absolutely world-changing agents in your IDE are, and specifically GitHub Copilot, is to solving real-world problems that you're looking at right now. But before we get there, let's go ahead and run these. Let's run our imports. And we'll define our large language model. We'll define our tool. Now, just using the tool on its own, because we have that tool decorator, we can invoke it. So evaluate math invoke, and we'll give it a couple of Python statements. And we're just going to run them all at once. And we can see we have 4 answers. It was almost immediate. And all this step demonstrates is that our super dangerous, no guardrails, parse Python and run it does work in our tool. Now, and this works, but I want to take a little detour to show you something. Now, I had mentioned it before, and I'll mention it again. There's no way to build robots without running code. I mean, you can. And for anyone whose passion is building robots, that is totally okay. But if you're getting deep into robotics, you have to write code. And if you're anything like me, I'm a jack of some trades, a master of absolutely zero, and switching back and forth between Python and C and C++, C# now, ROS 2, micro ROS. It's impossible to be a subject matter expert in everything. Now, up to this point, part of that learning process would be, in decades past, buying the books or buying the magazines. With the advent of the internet, everyone's familiar with Stack Exchange. Go in, do the search, work with Google, find relevant web pages to read, understand, and there. The next generation of that is to partner with an agent in your IDE, because it does all that for you. And I just want to show you something that I tried last night that was kind of, I don't know why that's there. All right. I've got a,
Just that bar,
yeah, how do you get rid of the bar? I don't want the bar. I don't want the bar. Okay, apparently I'm stuck with the bar. Yeah. All right. Let's just move it up there for a little bit. So, GitHub Copilot, it used to be $10 a month. I pay for it because I use it a lot. But even if you don't want to pay for it, there's a free version. All you have to do is sign up for an account, and you have access to some of the lower models, and you will find that it is exceptionally useful. Now, I have this in, oh, yeah.
So something I learned is they now let you use either Olama or like an OpenAI API or like OpenRouter for it, because I actually use it so much that it like runs out on the free plan, and I don't like the monthly. I like paying as I go.
I didn't know that that was an official option. It supports that out of the box now.
Yeah, I think they added it like fairly recently.
Oh, right on. Okay. Very cool. So even on the free plan, get an account. Even if you're a subject matter expert in whatever you're looking at, partner with the AI. Across the industry right now, these tools have been available for almost 2 years. Now, minus the lawyers and other stuff, over the past year, a lot of enterprises have also provided access to their developer team for this, which is great. But how do you best leverage it? How do you understand the capabilities and limitations in an ever-changing agent landscape to understand what it does best and how to leverage those capabilities while maximizing, your ability to produce and understand? It's a skill set. Just because you give this tools to your developers, most of them are too busy solving problems and writing code, so they may try it once. It's a real challenge. So there's real opportunities right now to take a moment to understand how to best leverage these resources in your enterprise so that you help your developers understand what they're good for and how to use it to be able to develop things faster. Focus on the stuff that you're best at while letting the agent work on the stuff that it's best at. It's a skill and a discipline. Much like 20 years ago, understanding how to craft Google searches to find the right, like it's a skill. So absolutely, get yourself a free account, take it out for a spin. It's a new skill set. It's a new way of approaching problem solving. And this is the way forward. This is literally how to solve these problems with less frustrations, and it's faster. There's a lot of stuff I do in personal life right now for this, as well as a little bit maybe at work, that I just wasn't capable of doing as fast as simply by understanding the tools available and making use of them. So to give you an example of that, check this out. I'd like to create a tool that is able to run random calculations. The tool should accept a Python description of the math operation, and after verifying that the operation is just for math and not anything else, go ahead and run it and provide the result. So it has in context everything in this notebook. It knows I'm writing for AI. It knows the framework. It knows I'm writing tools. I would like to write a version of this tool that's safe. And I'm just going to describe it in English. I'm not saying say you're a developer now because you know how to use GitHub Copilot, but check this out. All right, we're going to let it spin for a little bit.
Yeah, writing.
Yeah, at the end of the result, it should, based on the context that I'm asking it, write me a version of this function that is safe. And this is just a demonstrator. This is just an oh wow moment. And I'll be honest, I did this last night and then I stripped out all the safety to make the function easier to understand to get it started. And I'm not ashamed of that.
Curious. You have a bunch of repositories and you want to add Copilot to it. Will it read through the entire repository to build context?
I've used it in the context of how it's attached to Visual Studio and Visual Studio Code. I've noticed that there's some type of Copilot GitHub.com. I haven't looked at it yet.
Yeah.
I'm not sure.
I mean, if you're syncing your repositories in VS Code, Copilot.
Yeah. Yeah, I would imagine so. I just haven't had a chance to look into it yet.
Yeah, I mean, I don't use the one on GitHub, but I use this one a lot. You can pick which context you have. I think you may have shown that. It's up on top. It's showing you which context you're using, and you can add context. It also has tools to allow it to query for more context. But in general, it's too much to fit everything. I mean, you can imagine that it's going to get too big. So you tend to pick your context and then do it question by question. One thing you can do though is say, hey, please write a summary of my thing using these here, and then take the summary and use that as context. And that's pretty effective. Yeah, you just create another file, and then from then on use that summary as your context, and that makes it more usable.
Yeah, so let's let's see what it did. So it noticed that I was already in an evaluate math cell. So it looked through it and it gives me a little blow by blow of what it did. And it did a bunch of things. It updated our function, which we'll look a little bit next. It saw that there was a test cell underneath, so it updated that. And then it saw there was an agent defined underneath, so it updated that. And it set up even a new cell below that to demonstrate some additional capabilities. So this is what a time to be alive. All right, so let's see what it did. All right, so for those of you familiar with Git, what you're looking at is almost like a Git diff. It's highlighting in red things that it took out and in yellow things that it put in. So it is rewriting my math function and even gave it a different name. So it's updating the triple quoted text with examples and description. It took out my simple parse and eval. And it's defining a set of allowed operators and allowed names. And it's got a series of if else to validate that what the Python has is math only. And it's writing all of this on its own. And then it even wrapped the execution in a try except block, because even after those guarantees, it may not still be properly formatted. So let's capture that so that we can return something in that. Holy smokes. Right? If your mind's not blown, my mind's constantly blown, and I'm using this stuff every day, all the time. In the next cell, it went ahead and defined some variations on invoke, including some help text that kind of reiterates what the function is. It even has something to test error handling by passing something that's not Python, as well as some safety considerations. Can I do things like pull your password file, right? Like, talk about above and beyond here. And let's just fangirl or fanboy, a fan person, like just like, and so this is that virtuous cycle, right? So this wasn't possible 2 years ago. It wasn't possible last year. It kind of worked 6 months ago. But as we find new use cases for these large language models, those then form the fine-tuning data set to train the capabilities on the next generation. And in simply asking to write me a function, it has gone so far above and beyond. The test cases have been improved. We have negative test cases, failed test cases. It went through my entire code base and updated my tool list with the new version of the name. This is still okay. This was still okay. Holy smokes. Right, so let's go ahead and we'll go top to bottom. We'll keep these changes. And that was just me describing in English something that I wanted. It took into context what I was doing, and it went so far above and beyond, I was a little bit speechless. And this is why, in my 2 takeaways for today's talk, tools are easy. This approach is absolutely applicable to robots. Just as we wrote a simple function for how many fingers and a simple function for doing simple math, simple function for doing arbitrary math, that function could be used to collect a reading from a sonar sensor. You know, it could be used to collect a reading from a limit sensor. It could be used to drive a servo motor, right? And even on Arduino style projects, you know, adding some intelligence up above gives your robot the ability to control, monitor, reply on that. And that's without even being creative. So we're running a little bit behind. So let's wrap this up in the next couple of minutes. The last final notebook is an exercise where you just pull in the information from the previous notebook. So, and this is an exercise you can do on your own. I'm asking you to pull in the LLM statement. I'm asking you to pull over the tool definitions, set up the tool collection, the agent definition, I provided a slightly different version of the chatbot. I'm giving you a placeholder to define a system message, right? We talked 2 months ago about generally in agents and chatbots, you added a system message that defines the characteristics, limitations, behavioral traits that you want for the chatbot. Am I Nurse Ratchet? Am I a helpful AI agent? Is my purpose to pass the butter, right? You describe that in the system message. Do I want you to reply in pirate speak and everything in between? So go ahead and play with that. And we have the same boilerplate that describes that chat interface in Gradio. And after you copy and paste that in and run it, you now have a new version of your chatbot that has exposed the system message that allows you to describe exactly how you want your agent to behave. And your agent is able to tell you how many fingers you're holding up through a random. But more importantly, your agent can do arbitrary math. Anything that you can describe in standard operators, it's not going to hallucinate because it knows it has a tool that does math. It knows that the tool accepts Python. It writes that Python statement that executes the math you need to do, and it's able to report that back. How flippin' cool is that? So based on your appetite, we'll continue the series next month. These notebooks are all posted to that GitHub link that we posted in chat and is also in the message for anyone that's joined in today. I'll post the previous talk as well as this talk this weekend to our YouTube, so you'll have access to that if you'd like to review. And this whole framework, this whole subject area is super powerful. 2 takeaways: tools are easy. Turn your chatbot into an agent, and get yourself set up for VS Code, GitHub Copilot. If you have another IDE, use that one. But for everything that I do, from writing microcontroller code for ROS, Visual Studio Code does everything I need. So GitHub Copilot scratches that itch in a way that I never thought would have been possible 6 months ago.
Alan, can you paste the link again for those that came in later?
Yeah, for sure.
For them.
You go ahead and paste the link back in. There we go. And then, so Greg's got a comment as well about do an equation for inverse kinematics for a simple 2-link robot, and it gets it. For the commercial large language models, in that, where's the line for artificial general intelligence? We keep moving the goalpost. In my opinion, in many use cases, they are right now smarter than maybe up in the tier of the smartest PhD graduates in their chosen fields in any random area. They're a little lacking in common sense, but as we talk about that virtuous cycle, as we find new use cases, those become the test data and the training data for the next generation. So they're closing the gap. For anyone who says that large language models have hit their limit and will never get to artificial general intelligence, instead of boring you with all the incremental improvements that we've had over the past 2 years, I will simply point out that we are using a 4 billion parameter model. And 2 years ago, you were lucky to get a coherent response out of an 8 billion parameter model. And it went from maybe it'll work, maybe it won't, to trusting the model to write Python code for you over the course of 2 years. And anyone who says that it'll never work isn't paying attention to these incremental improvements that are being made. Have fun, go for it. GitHub Copilot, write an agent, write some tools, have fun with it. It's an amazing time to be alive. That's all I got.
All right, thank you, Alan. All right, so just an announcement for those that came in later and for anybody online and for everybody here, if you have a show and tell, let me know so I can add you to the list. And with that,
We'll break for a few minutes.
we'll take a little 5-minute break. For those that are here, bathroom is right next door here. And, up next, we're gonna have Evan from, Botango, who is gonna tell us all about, Botango.
Oh, man, I've been looking forward to this. It's gonna
Yeah.
be great. No pressure, Evan.
Looking forward to it.
As we have.
Pretty easy to follow along, conceptually, that makes sense.
Yeah, there's donuts and coffee back here for anybody that wants some.
have.
I know, I'm so sorry I dropped the ball on that. I'm gonna post them both this weekend.
Oh, it's.
Okay.
When I finally got, because like last week I couldn't work with, I realized I. So I, but then like I forgot the name, that's what I did for the dog. But, you know.
Okay. Yeah, it's very easy to modify for an OpenAI subscription, which is actually the easiest. There's a PDF in the GitHub that describes how to set up Olama to run it locally if you've got a machine that's capable of doing it as well, so. Yeah, sure, it's just like in the candy store, everything is so, that's been deep into it, and Jim is not here this month. Yeah, this is the future, we're living in it right now.
Yes.
Yes.
So that one for me looks like, I can. Yeah.
Yeah, agentic work in different frameworks and workflows went from experimental to a conclusion. And much like this, the capabilities that are produced so rapidly, things that kind of sucked on that. So even where we are. Right all on device.
Switched over. So I was explaining to her, and I found that.
Sure, the only lecture, the lecture that he gave, and all the files are linked that he posted.
I'm sure.
I need a file, so if you want to follow along.
Oh, I did not.
I like fire.
I thought you were familiar.
Yeah.
I worked here until October of last year. You brought your.
I've been using my cat.
Yeah, when all this stuff became mature, and I was doing some. For Josh. It was a matter of copying it in there. Now, it's happening in it's a requirement. Like, we're not very suffering without it. Oh, well, you didn't go to Google and type in the right keywords. Well, these guys are talking about gigabytes. Being an officer, to be honest with you, but now you say chastise them for not taking.
Oh, they still do, look,
Yeah.
by coding, right?
Yeah, that's what it is now, and as
Still need to have that. It's just WhatsApp, communicate on the. Exactly, yeah.
But then picture this stuff, right? So. The large language model knows all that. Like you have an instantly patient, super smart. That, how do they explain it to you? How do you examples, like, without just being like, right, this.
That's what I wonder, is it?
Yes.
I think ChatGPT is, but not, or whatever.
I'm sorry, like, what is?
It's been working, I've worked on. Like, and maybe it's easy, I think it's not just, just gratification. But like, I'll need a ball.
Yeah, I know it's, I mean, like, there isn't on state. That's really nice.
The worst.
Yeah, exactly.
Occasionally, I'll just start.
Yeah, you have to. That's
Like, hey, let's.
Yeah, you know, notice. I was thinking, like, you know, let's take this out, we're looking at AI.
And it actually, the next day, it actually happens, right?
Nature of it is that different interactions could have different results. Ideally, you always want the right answer, but especially like, okay, we're down a road. Hit chat, and like, okay, let's approach it from a different front. And then again, but it's all part of that skill set of learning how to work with it. And we're like, I'm not learning, but like, entire industry is right now, one thing has access to it, another. Yeah, so you mentioned you're about the campus site?
I'm right here, man, that's the,
Oh, sorry, nothing.
No. Yeah, I'm a kid. Come back.
You heard about
Yeah, and I know, I do other things, like, go 5 blocks, they can go around. Especially the only time you see that, what do you wanna do? Okay, I was gonna hear what the AI can do and what, you wouldn't have it turn on and off, so you might have it say, turn left, and then you have a turn left that does all the signal stuff. Yeah, because the AI is not fast enough, you know.
Yeah. Yeah, we're all sort of
Flying over, we're.
Yeah.
Yeah. Yeah, I was hoping I could. I gave a brother into that. We were going over some of the gear. I'm not sure how it works, because if you're. Out there. Going over the phone, it's so well. Really good.
All right, guys, let's continue on.
Let me give them the contact information. I would like to pass that along to his. If you're okay with that? Okay, I'll get that.
Oh, no, you're fine.
I know, I legit asked about your phone, she was like, I think. Just like, it can be.
I got like a, yeah. Pull out your old.
Get started?
Evan, you ready?
Yeah, I'm here. Can you guys hear and see me coming through?
Yes, we can.
Okay, great. Hi, everybody. I am Evan, the developer of Bottango. And for the most part, I apologize. I'm going to kind of be looking off this way because I got a multi-monitor set up. So I apologize if it doesn't look like I've got eye contact going on. But I'm calling in from Seattle. And thank you guys so much for the invite to be here and tell you about what I do. So I'm going to kind of really give you a rundown of what Bottango is and kind of first kind of go through a little bit of just a quick kind of preset presentation, and then we'll just get into Bottango and I'll take you on kind of a whirlwind tour of the functionality and the features and how to use it. But before I do that, because I'm, from a different state and still learning about you guys, I'm going to tell you all about me. I would love for just a minute or two to kind of get a better sense of who you guys are, or at least so I can, tailor the level of technicality, at least in what I kind of explained. So if somebody could kind of volunteer as tribute to kind of give me, like, is this a diverse group of experiences and interests, or is everybody here, they all, you guys all race micro mice? Like, somebody kind of give me that context would be great.
So we are a very diverse group,
Okay.
are, let's say, mature. Uh, uh, there's a sea of gray here. And, I mean, seasoned engineers to some of my students are here. They are just
Cool.
started in robotics.
Cool.
Kind of aim for the middle if you want.
Great. Well, yeah, I mean, Botango has kind of tools from somebody who has never even thought about building a robot themselves all the way up to industry professionals. So good fit. Yeah, so what is Bot Tango at a super high level, just like in a sentence? In a lot of ways, it's kind of the opposite of what you guys just watched in the previous presentation, not in a like adversarial way, just in a like it takes different tools for different jobs, right? Bot Tango is all about taking human intent of a performance on a robot, creativity, artistic expression, and trying to give you tools that as a person you have as little friction as possible to create the performance you want, right? For some context on who I am, I spent 20 years in game development, as helping facilitate in different ways the development of video games. And I learned a lot about how empowering creativity and creating cool tools for your creativity can supercharge your ability to create cool stuff, right? For every dollar you invest in a tool, you get $10 back out. So I'm going to go ahead and get my screen sharing going on. 1 second. Am I coming through?
Yes.
Cool. So I started this journey about 8 years ago, and this is going to be prehistoric looking, but this was my very first robot I ever made a long time ago. It was a lawn flamingo in my garage, and I, spent forever hacking together this lawn flamingo. And then I sat down and I thought to myself, okay, well, now I want to make it move with intent, with kind of expectation of what my performance I want it to be is. And maybe slightly different now than 8 years later, but even still, um, as a game developer, I was like, well, there are tools that I would use to create a performance on a character, and those tools are not code, series of numbers in a spreadsheet, blah blah blah. If I, as a game developer, said, okay, all right, now we need this character to do a performance on the screen. Here you go, write me the animation routine in C++. I'd be laughed out of the building, right? That's just not how we do creative work. And so I wanted to do the same thing on my character, but I didn't find anything like that, right? I didn't find the ways to use my traditional animation tools easily accessible for robotics. So you can see, if I spent a month learning how to hack this lawn flamingo together, I spent 10 minutes making this tool that let me translate, um, basic 3D animation over to my character. And I was extremely happy with how quickly that let me iterate. And that was 8 years ago or so. And I've been working on that tool since then. And it's developed into this whole thing that's been used from students and educators all the way up to folks in major industry places that I can't talk about, but kind of all over. So what is then Bot Tango, right? That is, the idea is take industry-wide standard creative animation workflow, the way you would animate a game character for video games, movies, TVs, anything Pixar that you might see on the screen, and translate that over so that the skill set that animates digital characters can one-to-one apply to creating animation routines for physical characters. So Bot Tango really combines three core sort of segments of functionality. a 3D modeling and simulation environment. Those same animation workflows that the creative industry uses, which at its core are creating keyframes along a timeline and massaging the interpolation between those keyframes, which is how do you move from one key pose to another key pose? You know, this would be a straight line. That's not a very expressive performance. You massage the interpolation of how you move from A to B, right? With something called a Bezier curve. And then that all combined with real-time hardware control kind of side of it. So here you can see here, really kind of just starting out basic, right? Creating two keyframes, and we're don't if this is all small and hard to see, we're going to really drill in and spend more time on this. But you can see here I am animating my, digital character, creating key poses along a timeline, and then it's playing back in real time on, digital twin between what I'm doing and what the robot is doing. So all really kind of basic, really, oh, not basic, but really kind of, standard animation tools brought over to the world of animatronics. So in Bot Tango, there are tools to model out your animatronic. So you don't have to come in with a kind of perfectly made model. So there's, right here, that kind of this sort of robot army looking thing was built in like 10 minutes with just the kind of simple primitive tools that Bot Tango provides you as a modeling environment. And there are ways for you to bring in your own 3D models. If you kind of have built things out in like a CAD environment or something and kind of get them ready to be used in Bot Tango. As an asterisk, and we can dig into what this means more, generally, CAD programs make pretty poor models for real-time simulation. So there are some caveats of kind of needing to clean up the mess that CAD models make when they're kind of importing out meshes, but that's a distraction from the big idea. Then you kind of model out in the application, set the range of motions of the simulation, the range of motion of your effectors, and you're able to animate. So you can see here, this is a much more complicated animation, right? Made through that graph editor, through that animation tools. If you've ever done animating in Blender or Maya or tried to do digital animation, you're going to immediately know what this is. And if you never have, if you ever kind of want to learn that side and you start messing around with Botango, you'll find, oh, well, this is just how Botango did it. And vice versa. If you're in Botango, you go, oh, this is just how Blender did it, or this is just how Maya does it. So it really is a translation one-to-one of a pretty core industry standard workflow. Oh, I don't know. Can you guys hear the audio from the videos or not? I don't know if I need to mute stuff.
You can if you select before you share your screen to
I don't need you to hear it. I just want to make sure it wasn't like blasting out your speakers by accident.
not.
Okay, cool. Yeah, so what is supported? Servo motors, stepper motors, dynamixel actuators, and basically the application itself is totally free. It runs on Mac, Windows, and Linux, specifically like x86 Linux. Unfortunately, ARM Linux isn't supported at this time. But Windows and Mac, and the application is totally free, doesn't require any kind of licensing or sign up. It's, just download the installer and go. And it comes with an open source Arduino compatible driver. And so, right, it takes two to tango. You need what you're doing on the computer and you need something to drive your robot, right? So you're not on your own with the functionality, kind of implementing it on your robot. Every piece of functionality in Botango, there's a sort of pair set of code in the Arduino compatible open source driver that kind of enables that functionality. So for folks that want to go out and build their own robot, but don't want to worry about the kind of code side of it all and just sort of create these routines and animations, it's kind of everything's handled for you. And then there are workflows and pipelines for you to add your own custom hardware. So we can get into what that looks like in a little bit, but you are not at all limited to these sort of sets. These are just the things that are like totally turnkey open box ready to go, but there's expansion in mind is kind of one of the key principles of how it works. So there's lots of opportunities for folks to do lots of interesting things with it and expand it and take it in their own direction, and folks really have. You can kind of use the application in two ways. You can do what we've been showing here so far, right? Where you got a computer connected and running the show, and it's kind of the show controller. Or there are ways to take these routines and export them out, either into self-running C++ code that you can just sort of embed into the driver, or SD card files if you happen to have an animation controller or an Arduino that can read from an SD card, and even into like raw JSON if you wanted to take the outputs of this and kind of run with it in your own robot controller and just kind of create these routines, you know, and the application, but then do your own thing. Here's just a couple folks that have used Botango and kind of the community projects that I can show. There's stuff that I can't show, but these are the ones, you know, recent, or just some of the ones from off the website where folks in the Botango community have used it. We do also have a very large and active Discord community of folks using Botango that come and help each other out and provide support. I am just one guy doing all this, so it's really helpful to have the folks in the Botango world that help teach each other and learn from each other and stuff. So if you're interested in this, I definitely suggest downloading the app because it's totally free, and checking out the Botango Discord community to learn it as you have questions. I'm always trying to help as I can too, but I am but one person. Um, and then again, I guess it sounds like you guys aren't going to hear the audio, and that's just fine. This was a recent Botango user was on. Is the audio coming through or no?
No.
Okay. Well, imagine there's cool dance music happening. This was America's Got Talent. This is Daniel Simu, and he used Botango to create his routine for his animatronic acrobat. Just let it play for a second. Sounds cool to see Botango's output on the small screen. Um, yeah, it was a really cool show. I actually just got to meet Daniel for the first time at the Bay Area Maker Faire just a few weeks ago and see his performance live. So I don't, was anybody at the Bay Area Maker Faire and able to see his performance? I can't, I guess I asked that question with no ability to see the feedback, so my fault. But if you did see it, Daniel uses Botango to kind of craft his routines. The last thing I'll show, and this will be the tiny 45-second sales pitchy portion of the presentation, and we'll go back to just kind of technical. How does Botango work as a company if the software is free and the driver is open source? It's one thing to want to animate a robot. It's another thing to have a robot. As everybody in this room, I'm sure, can tell you, building and designing a robot is super hard. So we offer 2 animatronic kits that have 100% everything you need in the box to build out and have these animatronics. We've got Maxwell the parrot here on the left and Captain Cogsbow the pirate on the right. So we support the company through sale of these animatronic kits that come with power supplies, servos, you know, the structures, the joints, everything you need to put them together, and including hardware control circuits. And with Captain Cogbrow, that's Botango custom design circuits. And here's Captain Cogbrow moving around in case you're looking for a fun Halloween project. Comes with everything you need to put together, and then you come in and can animate your own Captain Cogbrow. All right, that was my one sales pitchy portion. I'm going to jump in and start kind of showing how to use Botango and how to get familiar with the software. But any high level kind of question break for a second before I get in and show you how to use the software? Things that you think won't be answered by me kind of coming in and showing? I might rely on somebody in the room to let me know if a hand is up. Otherwise, I'll keep going because for some reason I'm not able to see the room very largely. I'm looking at my giant own version of myself.
I think we're good.
Okay, cool. All right, so I get sharing Botango. All right, am I coming through again?
Yep.
Cool. So this is where you are presented with Botango after you kind of agree to the terms of service and all that kind of stuff. So we're going to come in and just make an empty project so you can see how quickly you can go from 0 to animating a real world robot. So here we are. This was just clicking on this new studio project over here. Can you guys see my mouse? Is that coming through?
Yeah.
Okay, cool. So this is an empty project, right? And there's sort of this 3D scene. Up here at the very top is where we select what kind of overall mode we want to be in. Do we want to build? Do we want to animate? Do we want to bring in files like audio and 3D model files, or do we want to set up hardware? In fact, you can see we already connected automatically to my connected hardware, but I'll come back to that in a minute. So let's start off with just kind of starting to add stuff to our scene. So we're going to create a part, and down here, there's going to be a list of all the different kinds of parts we can add. A core thing we need is a motor. We have servo, steppers, custom motors, which we'll talk about that later. That's kind of part of that. You can add your own hardware and your own things to the application if you want, and Dynamixels. So we're just going to add a simple PWM servo, and it added it literally into the 3D scene. And now we have, when we have it selected, we can set it up. And I am going to just do some really basic setup here, which if you guys are familiar with how to use a hobby PWM servo, this should be really familiar. How do we kind of control this servo? We just say what GPIO pin we want. We want it on pin 5 for my purposes. I know that because with the hardware I have sitting on my desk, I got it hooked up to pin 5. We have some things we can use to start to tune it a little bit. We can set how fast we ever want it to move. But we'll just leave it here. This means the fastest right now it'll ever move is 3,000 PWM signal change a second. There's other kind of fun things we can do and learn, but we'll just keep it simple for now. And down here, we can set up where we want it to move from. We want it to move right now, and this defaults from at one end of its range of motion, 1,000 PWM, to the other end of its range of motion, 2,000 PWM. Because we're kind of targeting a different group of folks from different sets of kind of experience with the servo, you need to give it 3 things. It's got 3 plugs on it. You need to give it 3 things. You need to give it ground and power. That's 1 and 2. And then you need to give it a signal. The signal in servos is called PWM. Technically, it's not actually PWM, but we won't worry about it. It's like its own weird servo signal thing in microseconds. But if we're just learning the basics, 1,000 or somewhere around there usually means go all the way left. 1,500 usually means just stay right smack dab in the center. 2,000 usually means go somewhere around all the way to the right. And you usually have to massage those numbers because every servo is a little different, but that's the big idea. So I've done a lot of talking, but all we've done so far is, I'll do it again, hit create part, added a servo into our scene, and set its pin to pin 5, which is what pin on my Arduino or microcontroller the signal pin is plugged into. Okay. And now I'm just going to turn it on, and it is live. And I got things all wrapped up. I've got everything set up here. So now if I move it, the blur, if I move the servo and Botango, it's doing a nice smooth move on the servo. I'll kind of multitask trying to hold things up and keep it over. I could even come in and create a simple animation. I went over to the animate tab. I have a 10-second long animation. At the 0-second mark, I can set 1 keyframe where I want it all the way to the left. At the 3-second mark, I can set another keyframe where I want it all the way to the other direction. Stop blurring. And then you can see there's even a graph of how it'll move. I'll go back to the 0-second mark and I'll hit play. And it's playing through that animation. So in just a few clicks, right, I have created a smooth animation over 3 seconds from one end of its range of motion to the other, and have the opportunity to kind of keep going from there, right? This was really kind of foundational stuff, but you can see it's just sort of the beginning of what my opportunities are. One of the things that happened over here was Botango connected right away to my, I call it a driver to be kind of agnostic to what's on the other side of things, but you can just think of it as an Arduino, and maybe we'll just call it an Arduino right now, but it doesn't have to be an Arduino. So Bottango automatically connected to my Arduino. Why is that? Because I put, without any change to the code, I just kind of uploaded the driver that Bottango provides onto my Arduino, the open source firmware onto my Arduino, and then I plugged it in over USB. Bottango over here can see the list of all the ports that are available. It's going to kind of choose to like automatically kind of make a best guess of what it thinks your connected Arduino is, or you can be explicit and say, hey, I actually want to be on this exact port. And it's going to connect to it. And if it starts to see the protocol between Bottango and your Arduino, it's going to be connected and ready to go. So in terms of like getting things set up, it's pretty much that simple. You just need to put the code that I provide on your Arduino or Arduino compatible microcontroller. In theory, Bottango will usually try and just find it. If you need to tell it explicitly where it is, you can tell it. Once it's connected, then you set up your servos, you set up your simulation, and you start animating. So right now, we just have a servo, and we're moving the servo directly. And that's cool and all, and we can animate a servo directly, but that's not really a simulation of our robot. That's just a servo kind of floating in space. So let's say we had a really simple one joint robot. I'm going to move the servo out of the way, and I'm going to start modeling it out. Okay, well, I threw a cube. This is just a primitive kind of helpful visualization, but not actually impactful to the performance thing. I'll call it my base. I'll maybe size it down a little, move it around. If you've ever done modeling things like in Maya or Blender or 3ds Max, this is going to start to look familiar. So I've got a base, and then I'll create another, let's put a cylinder in it. And I'll just kind of massaging the size. I'm not basing this on any real world robot. You usually would, right? You'd kind of approximate your real world robot. But I'm just kind of doing stuff. And you can see here that this cylinder is inside of the base. Again, if you are used to how modeling tools work, not CAD tools, but like mesh modeling tools, this is going to look really familiar. The cylinder, we'll call this my like extension or something, is a child of the base, which means if I move the base around, the cylinder is going to move with it. That's a key idea of Bottango, is you create these what are called forward kinematic chains of parent to child relationships. A way to translate kind of forward kinematics is the knee bone's connected to the ankle bone, the ankle bone's connected to right. You move your knee, you're gonna move your ankle. You move your ankle, you're gonna move your your toes, right? So if I move my base, I'm going to move all of its children, the extension being its only child. Let's just go ahead and throw this servo by kind of dragging it into the base, into the base now too, right? So now if I move the base around, it's going to move the servo because it owned it. You could also think of it kind of like folders, right? If you move a folder around in your computer, everything inside that folder is going to move, including other folders. All right, so we have these kind of rigid blue things, which are the structures, but those don't move. So we need to make something that can move. Now, servos move in the real world. Joints are what move in Bottango. So we'll make a new joint, and this is going to be essentially our point of articulation. What is the pivot point? We're going to move it to around where we want the pivot point, and we're going to change how it pivots. Okay, so let's say it pivots right about there, and you can see it's going to kind of move up and down in kind of a head nod direction. And then we'll stick another cube inside this joint, make it long, move it over here like this, and we'll call it arm. Okay, so we have a base, we have an extension. A child of that extension is this joint, and a child of the joint is the arm. So if I move the base, it's going to move everything. If I move the extension, it's going to move its children. If I move the joint, it moves its children. And the arm just sits on its own, doesn't have any children. Now, why is that key? Because if we rotate our arm at the joint, that's going to move the arm itself too, right? So now we have the ability to set up a simulation side of things, right? We can say, all right, where is this simulation supposed to be at home? When it's moved all the way to one end of the range of motion, where do we want it to be? We can look at our railroad robot and say, it's actually kind of around here, move up. And then where is it at the other end of its range of motion? It actually moves a little less up from there. So now we have this restricted range of motion of what our robot can do. And we have a servo that can move. And we want these things to kind of move in unison. Well, it's as simple as click on the joint, click link on a motor, and click on the servo. Done. Now, as this moves, as the joint moves, as the simulation moves, the motor is moving too. And you can't see it because I'm tired of fighting the blur, but trust me that the servo is moving. Here, I'll show you. The servo is moving in real life as I animate my joint, right? So I've created that simple relationship in just a few clicks. So I can, again, to kind of restate it, I can set up the range of motion of my joint. I can set up the range of signal of my servo. And then when I'll blow it up and do it again. When I want to have a relationship between my simulation and my motor, I just click link to a motor. And which motor? I click on it and I'm done. So now, whereas before we animated that servo directly, now let's come in and we can animate our simulation and trust that Botango will put the servo where it needs to be. You can see even the little knob on the servo has gone away because it knows now, hey, we're actually doing things in the simulation, not directly on the motor. So I'll start at the 0-second mark at one end of the range of motion. I'll go the 3-second mark at the other end of the range of motion. I'll come in here and I'll see, this is what I was talking about, the interpolation curve. This is the graph of how we move from point A to point B, not just in a straight line, which would look like this. That's a really boring, uninteresting to the eye move, but with, with creative intent. So now let's kind of come back and see, it's kind of going to start slow, speed up, speed up, speed up, slow, right? If we want to massage and sort of change how it goes, we're going to go really slow for a beginning, and then we're going to kind of rock it down to the end, rock it down in speed until we reach the point. Now, this would be a bad move on our robot, but we're going to do it anyway. So, right? So, would you want to do that on a real servo? Maybe not, but if you had a robot and you throw a momentum around, sure. One other cool thing it's going to do is here, I'll come over here and make it more visible. I only set my max speed on this servo down to 1,000 PWM a second. So that's going to really kind of rate limit. It means, what, let's go even further. Let's take that down to 500 PWM a second. That means we really don't want this servo to ever move super fast. And now you see there's this little bit of a broken line on my graph. This is telling me, hey, you're doing okay on your speed, you're doing okay. Whoa, you're going to be moving way too fast there. And then you're back in the okay territory. So this little graph point there can be really helpful for figuring out, am I making a movement or an animation that's valid for what I want it to do? Now, let's say I send this to my servo. You can see it's really slowly moving back because we told it to keep things pretty slow. So when I do this kind of procedural move, it uses that speed. If I hit play on this, when it gets to that point where it wants to violate max speed, it won't. At a hardware level on the driver, it will only ever move as fast as that maximum speed. What that means, though, is it's going to be playing catch up on your animation. So by the time you reach the end of the keyframe in your simulation, the servo is still going to be moving, trying to catch up to where you were. So it'll play through on the simulation, but on the robot, it still has a while before it settles and kind of catches up because you set that kind of key speed limit. So let's back out of this for a minute and look at a slightly more complex setup. You can always access this here in this example project down at the bottom. This warning here is just because I'm running off a developer build and it's saying, hey, you're in a developer build, be careful before you save. So here I have a full kind of setup kinematic chain, and this can be useful too for learning and looking at it because you can see, instead of that simple, 1-point folder structure, we have a whole set of kinematics all the way from the root, which is the torso, all the way down to, let's say, this point, the hand, right? So if we move the shoulder, we're going to move everything, should be intuitive to you. We move everything under the shoulder. If we move the forearm, you know, if we move at the wrist in one direction or the other. So you can see how you can control that kinematics of your simulation going through. Each one of these joints is also set up to a servo. Another thing that's set up over here is you'll see we actually have two drivers, two Arduinos as well. You are not at all limited to running everything off of one. And Bottinga will do all the work to keep everything coordinated and synchronized between the two. So I have an arm driver and a hand driver. And if I look over in the status menu, I can see, okay, I have an arm driver, and these are the servos assigned to the arm driver. And I have a hand driver, and these are the servos assigned to the hand driver. And click on this button over to go and directly select it. And I can see which driver am I on, the hand driver, and all this kind of stuff that we've already looked at. And then you saw this in the video or in the presentation, you can see I have a whole full kind of sample animation here, again, using the graph editor, using this animation here. So using kind of pure math robotics tools, making an animation like this would be both difficult, time consuming, and make it hard for you to get your vision expressed on your robot. Using the graph editor, you can kind of come in and be like, okay, well, now that we did this, here's this shoulder movement. I see I kind of go here, but let's actually tweak that so we go a little bit higher up or a little bit lower. Oh, okay, I'm violating my speed here a little bit. That's kind of moved that back. And now I'm going higher without kind of violating my speed limit. And that was like 3 clicks as opposed to like, finding a bunch of raw JSON or something and going nuts. So you also can, if you don't, when you're keyframing and making this kind of animations, it's work. It's time consuming work. It's certainly faster than figuring this out in code, but it's still, making keyframes is laborious. So there's an option to come in and puppeteer and record that puppeteering. And after you're done puppeteering, it will actually run a curve fitting algorithm and convert your puppeteering result back into these same editable keyframes. So I'm going to make a new empty animation just so we can see it in one go. And unfortunately, I didn't think to grab a game controller or something like that, which is going to be a little bit more of a intuitive or kind of interesting looking puppeteering tool. So I'm just going to use my keyboard. So I'm going at a speed that I don't expect you guys to like memorize the steps I've done so much as just to know what's here and know what to look for if you're interested in it. So I'm going to make a new control scheme, which is how you map an input device like a keyboard or a gamepad or a joystick to a particular point on your robot. So I'll make a new control scheme. I'm going to make a new mapping, which is like, again, mapping between an input device axis and a robot axis. Add a control. What do I want to control? Let's start with just the shoulder joint. I just clicked on it. What do I want to use to control? It's going to list everything that it sees currently connected to your computer. If I had the foresight to think to grab a joystick out of my garage, I would have done that, but I didn't. So I'll just use my keyboard. I'm going to hit auto detect rather than look through the list of keys. I'll use the P key. And now it's mapped, again, this is a somewhat uninteresting performance tool because either my P key is down or it's unpressed or it's pressed. So could I do a much more interesting thing with an analog input like a joystick? Definitely, but this gets the idea across. There are settings here where you can play with, with how the input maps and so on, but we'll call that good enough for now. And I'll go to the beginning of my 20-second animation. I'll hit record and I'll start my performance. I don't know. I guess I'm doing the chicken dance. I'm flapping or something. Cool. I made my animation. I puppeteered. And now you can see that puppeteering, again, a somewhat uninteresting animation because I was just using the keyboard key. That came through and recorded, was edited. And I'm like, oh, you know what? I did this a little too soon. Let's just move that over. right? So you can come in and really mess with and massage your performance. Now let's say you want to add some audio performance. Come in here, grab an audio file. You know, different formats are supported, but it's WAV and OGG. Now we have an audio file in our library. We'll go back here, we'll add a track, add what do we want to add? We want an audio track. Cool. Now we have an audio file. I'm going to mute it in case it starts playing the audio. Now we have an audio file that we're able to use as well to animate with, and kind of synchronize that way. I'll jump out really quick to my Maxwell project to show you. When you get these kits, there's a cool, I'll show it in a second if we have time, 3D side of the whole application that shows you how to put it together. But there's also these template projects that are kind of built, set up, ready to go. You can also coordinate with video. You can bring a video in. So we've got this video player in the background, like maybe you have some performance you want to mirror. Maxwell comes with his own kind of cool video in the background. You can even like full screen it as you're going. So you can really kind of come in and play. Yeah, so I mean, that's kind of the big idea. Now there are a ton of more advanced set of features and functionality. For those that want to go kind of beyond these basics. I'm gonna maybe take a quick break to see if there's any kind of questions on this stuff. And then I'll take a pass on like, oh, does something like, does this exist? Does that exist? I'll kind of go over as much as I can, the more advanced stuff that exists. But any questions on the sort of core idea of Botango now that you've seen it working? And again, I'm gonna rely on you guys to tell me if anyone has their hands up because I can't see the crowd.
I've got a question on the hardware side of it. So it sounds like it has its own hardware driver that it loads onto the Arduinos. What if you have an existing piece of hardware that has its own format for giving commands to drive the joints? Does it have a way to interface to that?
Let's talk through that. So I'm going to stop sharing this, and I have the code up here. Oh, okay. Is that coming through? Is that working?
Yeah.
Okay. So when you get Botango, you get a .ino file, right? And a lot of the complexity is hidden from you. There's a source folder underneath this that the Arduino IDE doesn't show you. It's a huge project. There's 8 years of development on the Arduino side of things. What you're seeing just when you open up the Arduino is just the user-facing stuff for you to worry about. One of the places that I have is this. So when you get, if you're kind of just starting out and you just want to get your Arduino ready to go, you just open up this INO file, upload it to your Arduino, and move on. You're done. Now you want to start customizing things. Again, it's all fully open source on the Arduino side of things, on the driver. So every bit of the code is here. Again, like I said, the actual kind of core stuff is hidden in a folder underneath this, but it's deployed to you. It's just the Arduino ID doesn't show it. One of the main ways for folks to extend and kind of do their own thing with the result is this callbacks file. I'll actually look at it from the header side of things. And we'll look at it here. Every major life cycle event in the Botango app or the driver has a callback for you to inject your own logic. There's a callback when things first turn on. There's a callback when things are about to turn off. Botango runs this animation loop, and there's a callback before it runs its animation loop, and there's a callback after it runs its animation loop. There's a callback when a motor is turned on. There's a callback when a motor is turned off. And there's a callback every time a motor would change its desired kind of signal point. In Botango, I'm going to stop here, share back to Botango. There are these things called custom events, curves, on-off events, trigger events, and color events. And these are basically, I want to animate something, but it doesn't fit into a nice tidy box that Botango has. Maybe I want to animate some value between 0 and 1. Or maybe I want to animate some other value between on and off, right? So, or maybe I just want to animate a value, which is fire an event, or maybe I want to animate a color. So some of these will give you a little bit of out of the box functionality. Like I can have this on off event also change, a high or low on a pin, or I can have this trigger event, impulse a pin high or low, and that'll just work for you out of the box code free. Or going back to the code, I'll get this callback every time one of the custom events occurs. So every time the on-off event would change from on to off, I'm going to get a callback here and let you do something custom you want in your own code in that moment. So essentially, Bottango will fully handle everything to do with the animation timeline and the synchronization against that timeline of your different effectors. And then you have a nice cozy place to put what you want to do instead. And now this feels like a roundabout way, but I'm getting there. One of the things that you have in Bottango is a custom motor, which basically gives you a motor that instead of driving PWM or setting steps and direction on a stepper, gives you just kind of pure callback places for you to say how to drive that effector. So that is all both double duty of an explanation of one of the many advanced features of Bottango, but also one way you can integrate Bottango into another solution, right? Which is basically to use Bottango as a timeline owner, right? It's owning the timeline, but then kind of use your own code to sort of say what to actually do based on those kind of the data movement. Now, let's say you had another controller that can't even look at this code. Like it's just totally like this might as well not exist as far as what your hardware limitations are. So going back to Bottango again, and I think this might be closer to what you were asking. Let's kind of look at that example animation again. We have our animation, right? Let's say we're happy with it. We can export this out. We're not purely limited to just that live USB control. We can export it out. Well, what animation do we want to export? Well, we only have one in this project. It's this one. Which drivers, Arduinos, do we want to export out for, and which motors do we want to have? You know what? My thumb motor's been acting goofy. I'm just going to turn it off for now. Let's say you can kind of control it that way. You can, and if we're doing our own custom stuff, this won't matter as much, but you can also set up some kind of self-running trigger options like, okay, well, should it play on startup or not? No, well, let's not have it play in startup, but let's have it play every time pin 5 is driven low or pin 10, right? So it's going to listen then code free when the export out and run off of my own, logic here that you kind of did, or there are APIs and things for you to completely custom drive how and when these exported animations are played inside of the driver. And now here's where we finally get to what your kind of question was. What can we export out to? We can export out to self-running C++ code to add to that driver. We can export out to SD card files that can be read off of an SD card module if your Arduino has the ability to read an SD card module. Or, and this is you, we can export out to JSON, right? And this is just going to be a nice, cool blob for you to do whatever you want with. Now, is that going to automatically work with any possible piece of hardware that's ever been invented? No. You're going to need to write a translation layer between the JSON and what your driver expects. And there are ways to massage, it's in a different menu, kind of the settings of what that JSON looks like. But you don't have to kind of like extract out the data from my driver. I'll just give it to you, right? And for example, with the Acrobat America's Got Talent guy, that's how he does things. He wrote his own custom driver for his robot so that he can do kind of, uh, trimming towards, and kind of calibration as he gets sensor readings and stuff, but he wants the performance data itself coming from me, and then he kind of does his own stuff with it, right? So I think that's kind of the heart of what you're asking. So if you have some unknown thing that wants this data, you would export it out to JSON and then write your own converter to massage it to whatever your thing wants. Now, the one thing that Bottango doesn't currently support, and may in the future, is Bottango can't really run as a library. So like if you have your own Arduino robot drivery thing, the code just really right now isn't set up to be a module inside some other thing that's mostly running the show, because Bottango does so much timing work and so much other things that it kind of takes over and runs. So generally, it's possible to kind of libraryize the Bottango code, but you'll be swimming upstream versus using those callbacks to call into other systems. Roundabout answer, long answer to a short question. I apologize. But yeah, with 9 minutes remaining, I'm going to defer to you guys. Should I kind of keep going on advanced features or answer more questions?
There's no questions. Go ahead.
Well, I put in the chat, but I was gonna ask if you're able to puppeteer the robot, from the robot to Bottango.
Yes, with an asterisk. So in order to do that, right, you need a closed loop motor, right? If you did that on a servo and you moved your servo around, servos don't have any way of telling you where again, just a PWM servo. Servos have no way of telling you where they are, right? Stepper motor is the same, right? You start moving a stepper around manually, you've completely thrown off its homing. Who knows where the stepper is? So right now, Bottango supports one kind of closed loop motor, which is Dynamixels, right? Dynamixels, you are able to tell it where to go and able to read where to go. So if you use Dynamixels, you can what's called Waldoing, right? You can move around your Dynamixels, record that, and use that as an input scheme into the puppeteering side of things. What is not currently supported, but is on my roadmap, is the ability to do that generically with your own closed loop motor. So if you use that custom, what that will look like, but isn't quite there yet, if you use that custom motor flow to add support for your own custom motors, right? And you are using your own closed loop motor. Right now, it's unfortunately only one direction. I need to do the work. I am but what man, and it's free software to take the way that the Dynamixel side of things and functionality can read where the Dynamixels are and convert that into the puppeteering side of things to genericize it to any closed loop motor you might bring into the application. One of the things that I have learned in the years that I've done this is it is dirt simple, usually for me, to get something 80% working. Like if you ask for that feature, I'd probably have it 80% working in a day or two. And then it would take me about 2 months to find every possible way the user can break it, build the UI around it in the way that's intuitive. And I'm not saying that as like an excuse for where it is, just sort of to bring context on how each of these features typically come in for me is when I prioritize something, I usually get it working in like a day or two, most of the way, and then it takes forever to find all of the ways it can break. And I'm probably saying something that everyone in this room has had some kind of experience, right? You get it 80% there in a day or two, and you're like, wow, I'll be done with this tomorrow. And then a month later, you're still finding ways what you thought was done isn't done. So that's true universally, and it's true especially for me as I'm trying to build software that anybody can use to control any robot. The edge case hunting is often hard. Cool. Next question.
Can you use M audio key stations for input?
Say that one more time. I didn't quite hear you. I apologize.
You can use a M audio key station, the knobs and things.
Yeah, I'll show what that looks like. There's all kinds of functionality I didn't get to yet. So we're here, share Bottango again. All right. Okay, so I'm going to add an audio file into my project. I'm going to come in here. I'll just make an empty animation. I'll add the audio file. I'm going to come over to my control scheme. Again, don't memorize how to do this. Just know that it exists is more what I'm trying to get through. I want to add a mapping. So what mapping? Again, I'll just use my shoulder. And now what do I want to use? I have the choice of using an audio or video track or my microphone. For simplicity, because of the realities of kind of presenting over Zoom, we're just going to use an audio track. You can just use a live microphone. So which audio track? This one. And then you can come over here and massage how it translates movement to, ooh, that's loud for me. Mute the app. Okay. Oh, you know what? It uses this for this. Okay, so it's barely moving. So let's really boost. And you guys can't hear anything, right? But it's playing the audio in the background as I test it. And you can see this is sort of the waveform. We actually, you know what? Let's say we don't want to use the lower side of things. We want to use the kind of higher frequencies. Let's smooth it out a little. It's kind of too jumpy. So yeah, you can come in and do that. Now, all of this is here as functionality. I will say, personally, I have found that the performance that you can do with a joystick over one playthrough is usually a lot better than what the kind of just audio levels, even massaged, end up as. Now it's a cool way to do kind of a fast rough track and then kind of come in and massage. But I don't know, and maybe that's just my own personal taste. I certainly support it. It's there, it's pretty robust. I just usually find when I'm sitting down to do puppeteering, every time I try and do that, and then I'm like, well, what if I just use my joystick instead and kind of wiggle it the way I think it should wiggle and just play through my animation one time? I usually am happier with my wiggling than I am with the kind of audio level version. But maybe that's just my own taste. I don't know. Any other questions? Or
Do we have more questions?
No, just, what's the limit on how long you can puppeteer for and the recording size for it?
that's really going to be more of a computer question than a like hard software cap. I don't know that I've sat and recorded for like 3 hours. I can't immediately think of a reason why that would get silly and it would turn itself off or anything. But maybe if you, I mean, I guess I haven't really pushed that hard. I certainly didn't write anything that's like once we reach, 2 minutes, stop recording or anything. Um, I think in some ways that's going to be like, you know, how much can your computer handle of like storing that stuff and processing it as it goes and things. I don't know. If you use Bot Tango and you find that you need that to be larger than it is for some reason, and it's not just a like because your computer can't handle it, let me know. And you'd be the first person to sort of say, hey, I ran into this limit, and it would be helpful for me to know that. But I've not sat down and just hit record for 2 hours and walk back to see what happened.
Thank you.
Yeah, no worries.
Other question?
Yeah, it's kind of a related question. I was just curious what the INO and all the includes are, like the file sizes for those, just for storage on the microcontroller.
So an Arduino Uno is my min spec, an Uno R3 specifically. All core functionality needs to and will continue to work on a Arduino Uno INO. In fact, Maxwell ships with an Arduino Uno INO. Now, is there any space left over to like store animation data just on that, super old AVR chip? Nah, not on an Uno. An Uno, you already use like 75% of an Uno just with what's there. But again, an Uno has like what, like 16K or something, like tiny, right? Like on an ESP32, forget about it. You got room for days. I'm not exactly sure off the top of my head, but the biggest libraries that you're going to pull in are going to come down to what modules and functionality you enable on the driver. So let's go back and looking at this. So here's this modules file in the driver. And this is the default. I'm just running on an Arduino. Oh, you know what? This is in development. Ignore this. This is just the like bog standard I'm running on an Arduino Uno, and it basically has every advanced module turned off. Now, everything you've just seen, that's a standard module. I haven't turned off anything we've just seen. So I'll go through all of these other kind of cool advanced modules and talk about what they are and why you might want to use them. This is a really cool set of functionality on ESP32s. It's in development and the preview kind of nightly branch of Botango, not on the one that's on the website yet. But basically, you can use one ESP32 as a low latency access point for wireless control, and then connect in the number of other ESP32s as drivers to that kind of show controller wireless guy. So that's a way to, one, enable wireless control of your robot through Bottango with the one ESP32 as the kind of show controller access point, and then the others sort of listening to that. And then the way it's sort of configured and kind of intended to work is you can throw a whole show on that the SD card for that one, and then it'll stream wirelessly out to all the other connected ones. So that's kind of this set of things. Now, again, would an Arduino Uno ever turn this module on? No, it wouldn't even compile if you did, but that's going to start to pull in big beefy libraries like Wi-Fi and that kind of stuff. This is where you enable or disable if you want to use those exported out self-running animations, either from just code or from an SD card. Right now, SD cards are only supported on ESP32 and Teensy. Again, in small part, not fully, in small part because it's just the SD library is like 60% of an Arduino Uno's space on its own. So there's just not the budget on an Arduino Uno R3. On an ESP32, which has like 100x more size, it's fine, we're not even close. This module enables support for the ever popular Adafruit 16-channel PCA 9685 driver. I would guess probably a lot of people are familiar with that board. You know, it's that like that one you can get off Amazon for $4 that has 16 servo headers. There are pros and cons to using this with Bottango. Again, it pulls in the wire library for I2C, which is a big chunky one. So that takes up a bunch of memory. And also you have to start to use I2C for communication between the Arduino and the PCA driver. And on a faster board like an ESP32, forget about it, it's fine. On an Arduino Uno, it starts to add a little bit of latency, and it also takes up more of the very limited RAM on an Arduino Uno. So you can use it, but Bottango will actually turn down the maximum number of motors automatically that you can use when that's turned on, so you don't start to RAM crash. This is a module for if you want to play audio on your hardware. I didn't get into that on the driver's side, but you can enable that on any imported audio, and you can say, hey, don't just play it on the computer, play it on the hardware. By default, that will kind of just fire that trigger event for your callbacks to kind of decide what you want to do. On an ESP32, it's supported to use I2S to read audio files off of off of an SD card and actually process the wave data and pass it to an I2S stack if you have one on your board. Adjust volume dynamically. There's a kind of protocol for status lights on your board. If you need a stop button, like an e-stop button on your board, this is what can enable that. This can let you kind of remap pins. This can let you report a unique ID of the device. So you don't have to do a COM port hunt that we've probably all done and been like, oh, which port is this plugged into? Instead, it'll report a unique ID that's saved to persistent non-volatile memory. And then it'll just be like, you know, you can, that way you don't have to do the COM port dance and yeah, you can keep going. There's also in the Bottango app the ability to control the application via a REST API. So you can turn it on as a REST API server, and then you can command it from HTTP in your own Python code. Every single REST API command has a Python example of how to control it. I can connect to SMTP timecode for coordinating with a larger, show controller, which is a popular standard for like entertainment protocols and stuff like that. I keep going, but I'm already 4 minutes over. So yeah, I mean, I guess are we there? Are we out? Or any one last question?
No more questions.
Cool. All right. Well, thank you guys. I hope you enjoyed my whirlwind tour of Bottango, and it was great to meet you all.
Thank you so much. Thank you for all the work you put into Bottango. It's amazing software.
Just always excited to see what folks do cool stuff with it. So if anybody starts using it and makes cool stuff, let me know. I'm always that helps keep me motivated when I see this cool free software let you do something that would have been hard for you otherwise.
Certainly will. Thank you. All right, with that, let's break for lunch. Let's come back and welcome back everybody. I'm Ben, president of Robotics Society of Southern California. And we are back after lunch with our show and tell. And the first one on the list is Jim Ubersetzig. Go ahead, Jim.
Okay.
And for anybody that doesn't know Jim, Jim is one of our very long time members. He is an amazing engineer, very smart. He's done a lot of our contests and won a whole bunch of them, I think. Yeah, Jim, take it away.
Okay, Jim Huberstetson, welcome to the Robotic Society of Southern California. From time to time, we have contests for autonomous machines. This is one of them that's entered a number of contests. By that, I mean we can't use remote control in these contests, so the machine has to basically work automatically. This particular one has a gripper to grab things. It can roll around. It has a number of sensors. There on the bottom, side by side, are 3 little tiny sensors that look for a black line on the floor. For that, we probably would have to be out in the hallway. In case you want the robot as part of the contest to follow a line, it has color sensors that measure the red, green, and the blue components of colors. One looks down at the floor, another looks forward at something it might want to grab. Here's the distance measuring sensor. Measures the distance out this way. Now, I'm going to promote the idea that we should have another contest for these non-remote control robots, which is the main reason I'm going to demonstrate my robot today. This is a really simple one. I put the firmware into the flash memory here for a fairly simple task, which is basically to locate and pick up an empty can. Which would be a pretty simple contest compared with some contests. Well,
It probably works better in not in carpet.
well, it could be.
What are you using as a sensor?
Oh,
Yeah.
first try.
Are you using a camera or ultrasound or what?
Well, this is a distance measuring sensor. It's an optical triangulation type. So what it's doing is it turns until this thing reports, hey, there's something there. Then it uses that single sensor to kind of track this as it's moving forward. When it reports a distance that's really short, which means it's in here, then it knows it's a good idea to grab that. So that's basically the only sensor for this contest that it would use. It has plenty of other sensors, but for this one, that's the only sensor it's actually using.
Is it using PID?
Mhm.
Is it using PID?
Yeah.
My students just learned about PID, but
Yeah, I implemented PID. It has flash memory. So I used my notebook computer to write the source code, compile it, and load the executable file to flash memory. And then as soon as you turn on power, it goes. I put it with 2 switches, muscles and brain. And I discovered the hard way that it's better to turn on the brain first before you turn on the motors. Yeah, it's got separate, power supplies for the computer and for the motors. So what I would like to find out is how many people that believe that maybe within the next 2 or 3 months, they might have a robot for this very simple contest. Locate and pick up a soda can.
I would approve that one, since I know that several of our members have competed in that before. So I'm sure they still have the robots. Except that nobody is here that has competed in them. So, let's put it on the books, but I'm not sure, maybe 3-4 months in the future.
Yeah,
So
give
that,
people time to, because as you can see, this one is not perfect. It doesn't always pick up the can. I need to do some fine tuning. And I'm sure other people need to do that also.
update their
I think
robots.
You could build something from scratch. Yes, sir.
So like, 1,000 years ago in this club, we had one where it was a follow the line, and then there was a can at the end of the line. So you had to go to the end of the line, pick up the can, and then come back.
Yes, and this robot entered that contest with different firmware. Heck, that's all I've got.
I think it's different. Okay, so the next on the list is Jim Denuzio, my vice president. He is not here, but he sent me some videos that he wanted me to show you guys as his show and tell. For you guys that don't know Jim, he is another engineer. He's been a member for some time. He built one of our I guess more advanced robots called Big Orange. Big Orange is, I guess you can think of him as a rolling robot that has voice recognition. It has voice activated commands. Has cameras, it has LiDAR, it has a whole bunch of different technologies. The videos he wanted me to show you guys are of some new AI stuff that he added to Big Orange. So let me share my screen here. Share sound. Optimize video. Get this far out of the way here. Yeah, it's going. This is the presentation for Big Orange, Jim's show and tell. Big screen.
Hey Orange, move in the path of a triangle of 1 meter sides in clockwise direction.
I sent the move commands to trace a triangle with 1 meter sides in a clockwise direction and return to the starting point.
Hey Orange, move in the path of a square of 1 meter sides in a clockwise direction.
I sent the move commands to trace a square with 1 meter sides in a clockwise direction and return to the starting point.
Hey, Orange. Move in the path of a hexagon with 0.5 meter sides in a clockwise direction.
I'm gonna speed up the video. Okay.
I sent the move commands to trace the path of a hexagon with 0.5 meter sides in a clockwise direction and return to the start.
Hey, Orange. Move in the path of the letter L with long side 1 meter and short side half meter.
I sent the move commands to trace the path of the letter L with a long side of 1 meter and a short side of half a meter.
Hey, Orange. Move in the path of the letter U with long side 1 meter, short side half meter in a clockwise direction.
Great, I'll get my current position first. Then I'll send the command to trace the path of the letter U in a clockwise direction. Start at the top left, move down 1 meter, right half a meter, then up 1 meter, ending with my final orientation matching the start. I sent the move commands to trace a U shape in a clockwise direction with 1 meter long sides and a half meter base.
Hey, Orange. Can you trace the path of the letter J for my name? Ooh, not bad.
I'd love to. The letter J has a straight line down, then a curve at the bottom. I'll check my starting position, then send move commands to trace a long down stroke, followed by a curved base to mimic the letter J. I'm tracing the path of the letter J by drawing a long down stroke and then curving right at the bottom to shape the letter for your name.
Hey, Orange. Move forward 1 meter, then turn right and move forward 1.5 meters.
I sent the move commands to go forward 1 meter, then turn right and move forward 1.5 meters.
Hey, Orange. I want you to turn left and go forward 1.5 meters, then turn left again and go 1 meter.
I sent the commands to turn left, go forward 1.5 meters, turn left again, and then go forward 1 meter.
Robot with artificial intelligence would say, why are you making me do this?
Hey, Orange. Move in the path of a square with 1 meter sides in a clockwise direction.
For you guys that, have never seen Big Orange, kind of
Move in the
a-
path of a hexagon with 0.5 meter sides in a clockwise direction.
Okay, well, that was the end of that video.
Hexagon?
It looked like a pretty complex curve there.
This might be the world's smallest ESP32 drone, and you can build it. I call it the
Okay. This out of the way now. All right, and his next show and tell was oh yeah, his kit that he just bought. And for you guys that just came in, we're in the show and tell version. This were some show and tells that my vice president said he wasn't able to be here, so he just sent me the video, so that's what we're playing right now.
So here's the box, the robot dog kit. It is about $130, I believe, still, from Freenove, and does not include the Raspberry Pi, which can be a 4. In fact, it's recommended a 4B. The 5, I think, can work too, but and some other earlier models. But it's a kind of a fun kit. It's a great assembly task. Takes a bit of time. I'm not sure how good the walking and all that is. Not, you know, hugely great, but it's for that kind of price. It's a reasonable learning kit. Thanks. Alright, so here's the Freenove robot dog that I've assembled, and here's the app, which is a pretty good app on the Android, and it has also an app on Windows, which is not as slick as this, but it is reasonable. So here, let's see what we can do. First thing you can do is stand up real tall and then go down with this slider. And you can also move the head with another slider. Pretty good. And then the main walk, let's try, well, before we do that, there's this sort of a joystick kind of mode on the screen where you can go to any position. So here I can do downward dog kind of a thing, and then an upward dog, and then go right and left. And so this is the orientation. And now you can also make it work with the phone. So the phone's gyro affects the position. It's pretty good. So now let's try walking. Oh, that's sideways, sorry. So this is a side, I'm hitting the side button. Side step. It seems to do that pretty well. Now let's try forward. Forward is not the best. I think he's got kind of, unfortunately my poor doggy has a limp back left servo leg. So it's just, I've calibrated it, but it's just, it needs maybe it needs a replacement. The servo came not so good. And then, but backwards works pretty well. Better, way better than forwards. And then he'll go down into a position. You can also see what he's seeing through his camera. The camera is Raspberry Pi camera right here. The other thing it does is a balancing. So I'm going to activate the balance. Actually, I already did. So then, let's see. Up to a point, he will balance. He's making adjustments. There's obviously a limit to how far you can do it, but yeah, it's working, especially back and forth. A little bit to the side. Anyway, that's that.
Pretty much the end of the video. Well, thank you, Jim. All right, and let me stop sharing. Up next is Thomas.
You ready?
Do you want to take some time and go to the next, and then you
Yeah,
come
why
back?
don't you skip over me?
Scott,
Oh,
you're up, buddy.
so it's pretty short because it's not fully functional yet.
You're
I'm
up,
Scott.
You're up, Doctor.
This is Little
Scott.
Green. Yeah. It's just a humanoid I've been working on for a little while. He's all designed in Fusion 360. And it's been ported to Isaac Sim, so I've been working in Isaac Sim to try and get the training down. I'm using the Berkeley humanoid biped training model, but I was able to replace their robot with my robot and all my joints and specs and everything. So I've just been going through training. So hopefully it'll be walking next month.
Science project.
Yeah, it's got an IMU, so it's got the Orange Pi 5 Max for the brain, and then it's got two ESP32s. So one of them's running the IMU, and the other one is running all the motor control. And
What is it used for balance?
it has an IMU. It's right now it's a 90. I'm not exactly sure what model it is. So, I forgot, but I have a couple different ones that I'm going to try. But I'm able to get the sensor data into the Isaac Sim, which is good.
Is the sensor like kind of like a bubble thing that's like, or how does it know the different angles for balance?
It's a MEMS sensor, so it's like just a chip that sits like in the base down under here. So it can detect momentum, angular velocity, all that kind of stuff. And with the model that it's training on, it should be able to react quickly to like any kind of changes in momentum and adjust the motors and the torques based on that. So
And your ankles, is that like 2 degrees of freedom?
yeah, so it has a
Very nice.
and then I added a little
Well, so-
toe action. Yeah. So it has pretty wide range of motion.
Does it say stub your toe sensitive?
Yeah.
Had all kinds of troubles until I put a bent piece of wire sticking out of the front
Oh,
so that it would make electrical contact if it bumped its toes into something. That helped a lot because then you could write the software to kind of navigate around that.
yeah. No, that's definitely something I should look into because these are pretty flat and they're pretty sharp. So maybe at least rounding out the toes so that
If you make the toe portion so that when it bumps something, it automatically moves up, you could make that activate like a switch contact or something.
yeah.
So that it would know it stubbed its foot.
Yeah, I'm able to get all the torque readings from these motors. These are the ST 3215s, and they have relatively accurate. There's a little bit of backlash in them, but they're pretty solid, and they're not as expensive as like the Dynamixels. So that's why I went with these, but they definitely, the libraries are definitely like not great for the servo control. But it does have like batteries, so
Love the design.
thanks. Yeah.
Really, really nice.
Still working on, adding another like a torso, and I have like some 3D cameras I'd like to put in.
So are you gonna do like the entire humanoid? Cause like that looks pretty awesome.
I can plan to, yeah. Yeah, I'm not sure about arms and stuff yet. I have another one that I can bring in next meeting that's like similar to this, but it's like a Ryobi based thing, so it works off of Ryobi batteries.
So, but, I mean, right off the bat, what I see is that the higher you go up, the more stress, the more weight is gonna be on the servos and, yeah, you might max out the servos of what they can handle if you go up higher, like, build more body, more weight.
Yeah, because he's already, I can't remember what he was saying that, but these servos are supposedly rated to, I think 20 kilos. So they're pretty strong, and torquey. They're able to break, like just doing some of the sim to real tests, like his legs were like, wow, like all the way up like this. And they were actually able to break some of these plastic parts. So I had to reprint some of these things. You can see they're different colors. Like these are now in ABS, so they're a little bit stronger than the PLA. But
You might consider making the torso out of like really lightweight foam rubber and just put like a really thin shell around it so that it doesn't have weight.
yeah,
Yeah.
yeah, and then additional servos would also add, more weight as
Not
well.
much you can do about weights.
Yeah. But it's coming along.
And you said, what did your name?
Little Green.
Little Green. Yeah. Sorry, so there's Big Orange and Little Green.
Yeah, so
Still.
he's Ross too, for all the motor control. And then, so right now, since the Isaac Sim, so I'm training the model will run on the Orange Pi. And then and that'll work with the Ross too, on running micro Ross on the ESP32s.
What have you done, like, in terms of testing? Have you got him to try to stand up to see if he can support his weight, or have you tried?
Oh, yeah, he could definitely support his weight.
Nice.
And just straight motor control, like everything works. As far as the testing, and he's definitely strong enough to walk. Right now, it's just the sim to real gap is where I'm at, because the training looks good in the simulator, and I can control like forward, backward, side to side, everything with the game controller in the simulator. But putting the code into the actual, like calibrating motors, getting them all like set up right, is where I'm at. So actually, I'm open for anybody that wants to help me with it too. So if anybody has experience.
You mentioned something about this, like the servo library.
Yeah.
What's going on there? Because I built one for those servos before.
Oh, okay. I think I don't know if it's the speed of data transmission.
Like the update rate.
Yeah. Yeah. And it could just be because of the number of servos. Yeah, I'm not sure if it's the communication, because they're serial, so they're connected in chain. So I'm not sure what the total throughput for the data is.
Yeah, because it's got to send it, their address, and it's send it to one and the next to the next, and it's like going round and round.
Yeah, so like if I look at the Rust topic, like if I echo it out, I get like really good data. I'm running at like 50 hertz or something like that. Yeah, and I get good data, except like every once in a while a servo will drop out and I'll get like zeros. But overall they run pretty good, and I'm just trying right now. I'm like just ignoring like the zeros. I'm just like cutting them out of whatever processing. But
What kind of servers are you using?
these are ST321 I think they're a Meetup knockoff from Waveshare. I think they're Waveshare.
Yeah, Alice Kim has done a lot with the serial servos with feedback, so.
Yeah, and I think it's Seed Studio has a really good robot kit that has like they have a higher gear ratio than these in the same servo setup.
So is that like 8 servos?
It's total, I think it's 12 right
Oh,
now.
that many.
Yeah,
How much did they cost you?
because I got this. These are like $25 a piece. Something like that. Yeah, 25 is. We got 1, 2, 3.
Those are standard.
No, 6 per.
Remote host servos, right? They're not serial.
These are serial.
Well, they are serial.
Yeah, yeah, these are serial.
That's good. At least you know where it is before you start moving.
Yeah, exactly. They report on position and torque or a semblance of torque.
From hobby servos.
Yeah,
When you start.
exactly. Yeah. And so, I mean, it works pretty well. Then I like using them. They work better in my design because I'm able to actually hide the wires a little better. And in the final design, I'll probably hide them even better than this. I get more integrated into the body.
You said that one of a few of their parts are ABS. Is the whole body ABS?
So these lighter green parts are ABS, and then these blue-green parts are all PLA. But I would, if I was going to redo it, I mean, when I do redo it, it will be probably all ABS, just for flexibility, durability. I thought about maybe reinforcing some of the servo horns with like sheet metal.
Okay.
Maybe stamping some parts or something that wrap the horns just to give them more rigidity. Yeah, and you can see I only have like 2 screws in some of these horns just because I'm frequently taking the limbs off.
Yeah.
Pretty cool.
Thanks.
Thank you, Scott.
Yeah, Rennie's on will be. We have 2 things to show you today. This is a very early prototype of a robot that's going to have AI, and I've been working on the AI constantly more than the robot, so that's why it's basically a head on a stand on a this is a Segway scooter here. The good thing about the Segway is it has a built-in follow me mode. So even though I have no software coded on this, it will follow me. And usually it's pretty good. Occasionally it gets lost. I'd like it to have it in front of me or sideways, but no, it's a follow me mode. It's got a little bit of a swing to it. This is not the way it's supposed to operate. Not with all this weight on top. This weight, I originally had it 5.5 feet tall, and that was not working very well because it would tend to swing back and forth and sometimes fall over. Excuse yourself. The head-on music here has these eyes. It's called the Snake Eyes. Look it up. Snake Eyes hat for the Raspberry Pi. They were working, and then the SIM card got burned out, so now I have to burn a new SIM card. When I get
the eyes do when they're
vision.
Oh.
Anyway, the good thing is when this thing's in neutral mode, I can just kind of push it around, and I can turn it just by leaning it. And go forward and go backwards.
So the reason that it does that is because it was originally designed to have somebody stand on it. The way they lean would be the way it would go.
If I put a set of arms on here, when it would reach the arms out, the center of gravity would go forward and it would go forward.
I suppose it would, yeah.
And I could do the same backwards. The only problem would be turning, because if you have to move the whole thing around left and right, and that would be a bigger servo motor unless I got down and disassembled it and found a little piece underneath that was going left and right and use that. But I'd rather not, because as is, I could just pull this off and ride it right now. This thing's an expensive piece of machinery. Anyway, I have one more thing to show you. I have no name for this robot yet. It's basically, a head on a stand. I don't know. Mrs. Headward or something. I don't know.
Stanley.
Standy? Yeah.
Stanley.
Power go down. I have a kickstand, which is very nice. So when the motor's off, it doesn't.
Okay, so I've been working on a lot of AI. I mean, a lot. About a year ago, I was working for Honda. And I was in their, one of their exciting departments that you've never heard of, so don't worry about it. And then they outsourced my job, and so I had a lot of free time on my hands. So I went headfirst into AI. And there's a lot to go into. You know, you read about, ChatGPT and Gemini and all that. And you're up here because this has been going on for more than 10 years, and it only came to the surface back, 2021 or something, 2022 is when they first started releasing the first models. And so there's a lot of catching up, and I started writing books on the subject just so I could be educated. I could learn more by writing about it than I could just by going to a class or something, because I'm building. And then I wrote books, and then I'm up to 4 books now. I'm working on my 5th. The first book was the AI dictionary. You can look it up. Hey, can you put that on the screen, or shall I share my screen? I'll have to share my screen eventually anyway. The AI dictionary by Thomas Messerschmidt. You know how to spell my name?
It's difficult, but how do you spell it?
Yeah, maybe I'll just share my screen.
Can you make it less of a commercial?
I'll do my best. I'll give a free copy here to anybody who wants one. How's that? Does that make up for it? I know. Anyway, you can look it up. But I've gone through something called RAG. Anybody familiar with RAG? A RAG pipeline? This one. Okay, he comes to my meetings. We have meetings on Thursday nights. We do the AI meetings. We're the AI SIG now. We used to be the big SIG of the homebrew robotics club of Northern California. And RAG is a way of getting your data into ChatGPT and separating it from ChatGPT's training. Because let's say you have a special product and you only wanted to draw from your information, no matter what that is, then you can load all that information as big as you want, as much as you want, and send it all to ChatGPT through the so-called RAG pipeline. I wrote a book on that. It's kind of fun. I'm going to put chlorine into the pool. And then next, I'm working on building my own large language model. Anybody here build their own large language model yet? It's not that easy. It's not like you can go out on Amazon.com or anywhere and find a book that says building your own large language models for dummies. It doesn't exist. And then you go and you say, you're reading my mind. But the good thing is this thing called ChatGPT. Anybody hear of that?
Oh yeah.
Yeah, okay, one guy. All right. It's the most wonderful thing about the modern AI, modern large language models is they're excellent tutors. They will teach you things. They won't laugh at your dumb questions. Okay, they won't make you feel embarrassed because you asked the same question 3 times in the last 30 minutes. Okay, they'll define even the smallest words that, like, you're with your friend, you go, you don't know what that means? Come on. And it'll bring you right along and encourage you all the way. And I want to recommend it for anybody who's learning anything about anything. You're balancing, trying to get your robot to balance. Maybe you can ask ChatGPT or Gemini or Grok. Is that the right word? I think when I say grog, like a caveman. But anyway, and it will guide you along the way. And it's wrong sometimes. It's wrong a lot of times, but it will correct itself. And it'll help you write code. And that code will be buggy. I guarantee it. Especially a large program will be buggy. And then you'll send it the error messages. Exactly. And they'll say, oh, well, that's because you don't have this library. Oh, well, why didn't you tell me about that before? So I add the library, and then all of a sudden I get another error message. Oh, that's because you didn't do this and you do that. And eventually the program runs. So that's what I've been going through, and now I'm building my own large language model. Why? Because it's there. I don't know. Because I want to learn how to do it. And that's going to go into this robot. I'm going to build my own large. There's the connection back to this robot. You see, it's not just an advertisement for me and my books. Messerschmitt, long German name. Hard to spell. SCH, yes. And I'm doing this, and I've actually managed to learn all about voice recognition software, because there's several different models called Whisper. Anybody hear of Whisper? Yeah, Whisper's really good if you want everything on your own laptop. Because let's say you're here at beach, down here in Long Beach, and there's a lousy Wi-Fi, or you can't connect to the Wi-Fi. Well, you're lost. Your robot's no good if everything you rely upon is on Wi-Fi, on the internet. So with Whisper in a local model, and not this laptop, I got a gaming laptop at home. You need a gaming laptop if you want to run a large language model, and you don't want to wait 2 minutes plus for some reply. So that's where I'm going with this. Put the large language model on top of the voice recognition model, put it all on a beefed up laptop, and run it on that robot there. Gonna put the laptop right underneath the bottom there, strap it on. So I don't need a Raspberry Pi loaded with all the bluebirds, all the hats, AI, because it's all gonna be on one laptop. That's where I'm going with this, yeah.
Instead of using a regular laptop, why not you use a mini PC?
That's possible too, but I wanted it all in one package.
Oh, okay.
I wanted it to be easy, so I could if something broke down, I didn't have to log in. I just opened the thing up, start programming.
Got it. Oh, yeah, you're right.
Keep it easy. That's my bottom line.
If you're building your own LLM, where are you getting your training data?
Oh, it's all over the place. You know Hugging Face, right?
Hmm?
Hugging Face. It's a website. I don't know the full URL. I don't remember it. Anybody here know Hugging Face? What's the URL for?
It's huggingface.co.
And it's got humongous files with humongous amounts of data to train anything on. And I've downloaded, oh God, they're huge files. They can take hours, if not days, to download. And it's like silly data right from the internet, conversations, and some of them are books. And then, I'm sure some of it is copyright protected, but oh well, let the lawyers figure it out. But yeah, that's where it all comes from. It's all free out there. You can do this for $0. You don't have to pay anybody for anything for this. And that's going to be my 5th book. So I'll report back when I get more progress on it. Thank you.
Thank you, Thomas. Any other show and tells?
I just wanted to say, so I had an internship with AWS, and they taught a little bit of AI. If you're making your LLM, I guess when you have all that data, I would say just you have to do some type of data cleansing. That way, yeah, right. Okay, so
Yeah. I've got the outline for the book actually.
Okay. Yeah.
Thanks to ChatGPT, gave me a great table of contents.
Nice.
It's not writing the book for me. It can't. It just can't. And I thought that would be a great shortcut after the LLM write me a book on LLMs, right? No, it comes out with garbage. It's really trashy information that's pretty much useless. I mean, some people publish it and call it a book, but I won't.
AI slow.
AI slow. There's a proper term. Yeah.
Yeah.
Anybody else? Okay, that's we'll call it a wrap. Thanks everybody for coming to the October meeting of the Robotics Society of Southern California. With that, I will stop the recording.